Tell me something. Let me see if I can hear you.
Hello, sir.
Ah, yeah, yeah. Okay, okay. The mic is mute. Now tell me something. Am I audible?
Hello, hello.
Yeah, yeah. Now I can. Okay. Okay. So it was mute from my end. So, in the last lecture, we saw how to cut elementary for a certain situation. So we found area. So we found the area of the cone in the last lecture, right? Now we'll find the area of a sphere. Surface area of sphere. So whenever we have three-dimensional object, and if you wish to find the elementary area, so for a spherical object, the way of cutting is very unique. So what we exactly do is, we first of all, from the center, we move to the surface. So it means you are already at some place here. So you move from the base, let's say the equatorial plane in a way, and you move to some location. So let me make it three-dimensional figure, just for your understanding. So first step is you move some angle from the base. You can move from top also. It really doesn't matter. And you move by some angle theta. At theta, you make a cut. So what is the meaning of cut? You keep the angle constant, and let's say this is the tip of the knife. So making the angle constant, if you rotate around this axis, so if you turn around the, let's say z, let's call y axis. So if you turn around the y axis, keeping the angle theta, you make a cut in the sphere, and the cut will appear as, look at this cut. This is a circular cut. Do you realize this? The cut is circular. Yes or no?
Yes.
No. So the moment we know this is the radius of the sphere as capital R, and we know the cut is made at angle theta. So if you look at the every point of the loop, this thin circle which I have drawn, you can realize that this is a circle of certain radius. So can you tell me what is the radius of this circle? What is this radius, guys? Tell me. So we have two variables, the capital R, which is the radius of a sphere, and the cut angle, which is called theta. So what is the radius of this circle? Tell me.
Sir, R sec theta.
R?
R sec theta.
Are you sure? Are you making some mistake?
R cos theta.
Yeah, correct. So how many of you are able to understand this radius is r cos theta? Raise your hand. Let me see all of your hand. Okay. So rest of you are not able to see that it is r cos theta. Okay. So only two can see. Okay, Kanu can see, yeah. And Rugwe just joined. Yeah, Shreya you can't see, eh? It's a r cos theta. So do you see the triangle? If this is theta, this is also theta. Alternate angles are equal. And in this is a right, you can look, this is a right angle triangle. So we should be able to find the dimension once we know the one of the side and angle, because in any right angle triangle, two informations are sufficient to solve. So we can see R is Now, if you would have taken theta from the vertical, the only difference is this would have come r sin theta. So in a context, sometimes we do take theta from the vertical, but for the present discussion, the theta from horizontal is good enough. But we need some surface. So this is a cut, and definitely it is not a surface. So to get the surface, we need to make another cut. But yeah, what is variable? If you look at the variable, what is the variable here? Is capital R a variable? Is capital R variable?
No, sir.
Is theta variable?
No, sir.
Theta is not variable. So as you change theta, the cut will be same or different.
So theta will be variable.
Theta is definitely a variable. No? So as
So
I will change,
small r would be variable.
yes, so a small r is variable due to what? Due to theta only, no? Correct? It is a theta which is changing the small r. Yes or no?
Yes, sir.
So as you make the angle grow in its value, the cut will be made at different height or different altitude. Yes or no?
Yes, sir.
So what we do next is we make another cut, but this time while making the another cut, we have to make sure that it's very close to the first cut. So this is like a prerequisite. You must make a cut, but not too far away. Now the question is, why not too far away, sir? Why not? Because the whole idea is we would like to keep the what? The radius constant. So that is only possible if we make the another cut as close as possible. So how far will be in terms of angle? The next cut will be exactly d theta ahead, isn't it? So to make it a bigger diagram or better diagram, I'll make like this. I'll show you. So you make two cut, one you have made and the other you are making. And the first cut is like this. So you make two cut. And then these two cut will give you a small surface actually. So the first cut, as you can see, we made a theta. And then we say mathematically that the next cut is exactly d theta away. So we make theta cut at angle theta. And then we make the next cut at a d theta more than that. So which is theta plus d theta away. And when we do so, we get a surface. And what we believe that this surface is having almost constant radius. So although it looks like a kind of tapered cylinder, tapered means it's upward shrinking. So this is like a tapered cylinder, but we know that it is not much tapered because the dimension is almost same. So if you, even if you try to draw slightly a tapered face to mimic this situation, the approximation that we are talking about is d theta will let you believe this is a close equivalent of a cylinder. So these all are assumptions, like mathematical assumptions, which is in place for a long time. So just believe that this is true. So the radius that we are talking about here, and of course this is counterintuitive, this is R, this is R, this is R. So the biggest challenge is how to find the height of cylinder. So the height of cylinder in case of curved surface is not taken vertically, it is taken along the slant line. So as a thumb rule, which you need to remember, that for any curved surface, it is mathematically accurate, or you can say more accurate, to take the slant as a height instead of taking actual height. So while calculating the area, this is the most important part. So I'll make it L, which is the idea of slant length. So height of cylinder we always take as the height of not cylinder of element. Okay, let me write down everything once again. So height of elementary cylinder over the spherical surface is taken as the slant length instead of vertical length while calculating it. Understood? So height of elementary cylinder over the spherical surface is taken as the slant length. This is spelling mistake. Slant length instead of vertical length while calculating area. And therefore, this slant length is very famous. From the circle, we know this is d theta, and this is the radius is r. What is the slant length in terms of r and d theta?
RD theta.
Excellent. So always remember that the height of this cylinder will be r d theta, and the radius will be r cos theta. And what we are trying to calculate? The curved surface area, right? So the curved surface area will be how much? Now this is a simple cylinder, and we know the formula. So what is the formula? Tell me. What is the formula? And you can also think like this: if you take this thin strip and if you cut and if you spread, the width of the strip is actually the slant length. Do you realize this? The width of the strip will be equivalent of the slant. Yes or no? Do you guys realize that the width of the strip is equivalent of slant, not the vertical height?
Yes, sir.
So now tell me what is the curved surface area of cylinder formula?
Fire
Pardon?
2 ounces.
Okay, you can just spread it. Now you can
Yes, sir.
cut like
2
this.
pi action.
If you cut and spread, what will you get? A rectangle again. And the width of the rectangle we can take as r d theta. What is the length of the rectangle? It's equivalent of perimeter.
Yes, sir. 2 pi.
So this area is how much? Tell me. Is it difficult to say?
2 pi r cos theta into r d theta.
Very good. So this is dA equals to 2 pi r square and then cos theta d theta. So you want the entire area. So you must vary the theta from minus pi by 2 to get the bottommost point, 2 plus pi by 2, the topmost point. And I hope you can do this integration. So tell me what is the area coming? So cos theta will give you sin theta. And sin theta from pi minus pi by 2 to pi by 2 will give you how much? So what you can realize or see that the area is 2 pi r square. You know, there is a shortcut for this. Anyone knows the shortcut? A sphere area is equivalent of the corresponding cylinder which you can cover. So imagine a cylinder covering the entire sphere. Imagine you have to buy a box to pack this globe. So you will make a cylinder just big enough to cover the. If you take the shadow of this sphere over its wall of cylinder, tell me what is the surface area of the cylinder? Because it is just packing this sphere. So the curved surface area of cylinder is how much?
2 pi r s.
2 pi r into L. L is how much? The height is? The height itself is 2r. So the curved surface area of this cylinder is how much? Perimeter 2 pi r into height, which is exactly same answer. Okay. And that is very interesting. So you know that next time you want to you put some spherical object into a box, then the box can be made very easily. Just draw a rectangle of length 2 pi r and height 2r, cover the top and bottom, and then you can exactly fit the sphere. That's very interesting. Okay. That is something very famous and very much known, and it's good to know. Okay. Next. The next is, so you know how to cut elementary in case of sphere, everyone? Is this clear?
Yes.
So we have found the volume of everything which we needed. Sphere, sorry, surface area of everything. So we found the surface area of sphere, ring, okay, disc, done, circle done, cone is done. Okay. So any other shape you want to find the area? Curved surface area. I mean the area actually simply area. So you can find the area of anything. Let's say there's a concept of surface of a revolution. So what is this simple concept? So imagine if I give you a triangle. Let's begin with something simple. Imagine if I give you a rectangle of length A, height B. And then what I do is if I sweep this surface giving one complete rotation. Oh, I'm looking for surface, not volume. Just a minute. Okay, we're looking for surface of a revolution. Yeah. Just a minute. I went to the volume of revolution. Okay. So imagine if we have a line. I can take vertical line. And this line is at a distance A away. Let's call R away. The height is H. Okay. So if you rotate about the y-axis, giving one complete revolution, this line will trace some area. Can you guess the area? What kind of area it will trace?
Cylinder.
Exactly. It is going to trace a cylinder. So the surface area of this cylinder is called surface of a revolution of the line, which means if someone will move the line or revolve the line around a given axis, it will trace this particular shape. Okay. And what is the area you can see? The area is how much? So area is 2 pi r h, isn't it? The curved surface area we know is, you know why? Because I can take a strip. So what I'll do is the general method is you take a strip. And this strip I am taking from y to dy. So what is this area? No, what is not this area? Okay, we just need a length. So what is this length? This length is dy. And in one rotation, you will trace a small cylinder. So what is the area traced by this rotation? So this area we can write as the dA equals to 2 pi r into dy. Correct? This is the surface area we should trace. But fortunately here what is happening? The r is constant. So that's why the net area is, and the y will go from minus something to something, but the net value of y we have to measure from h. Okay, this is eventually. Okay, now imagine this situation. If I plot the graph, y equals to root x. And what you are supposed to do is you're supposed to rotate around the x-axis, and once you rotate, what you get? A surface of revolution, something like this. So upon rotation, you get a surface of revolution. Another question is, what is the surface area of this object? Okay. Let's say this is, we are finding up to some height r. So the way of solving is this: you take a small piece of it, so you move x, then you move dx away, so you get a slant length, and this length we can call dl. And then if you move the one rotation, then the area traversed we write as 2 pi. Let's call this is y. So the radius is 2 pi y. So perimeter becomes 2 pi y. And we always multiply with the slant length, which is dl. So in one rotation, you will actually trace this much area. I hope you can see this trace part. And this is the area you're tracing. So in the case of cylinder, the y was constant. It is same everywhere. Now its y is variable. But we know the method. What you do is you just write a perimeter 2 pi y, because in one rotation you will trace a perimeter of 2 pi y. And perimeter into slant length is called the curved surface area. That's the definition of any curved surface area. So curved surface area we write as perimeter into height. Okay. Not slant, I mean not here. Perimeter into height. And this is only true when the perimeter is constant. So what is happening here? In our case, as we move from origin towards right, the perimeter will grow and grow in value. So it's a variable perimeter, and because the perimeter was variable, so to apply the formula of area, we have to make it small enough, and it is so small that the variation can be ignored, can be thought as a cylinder, and every cylinder is a wrapped rectangle, and we know the formula of rectangle, we apply it and we get the area. Why we are doing this important? So why we are doing, because the formula is not applicable for the entire thing. So our effort is to convert into a format where the formula becomes applicable. That is the whole idea. Are you guys getting this potential?
Yes, sir.
So the whole idea here is that we make a small enough or elementary size object, because only elementary size object can be expressed in terms of rectangle. Any other size is not rectangle. It is either rectangle only, and if it is not rectangle, then we have to make a small piece of it which can behave as rectangle, so that you can write the formula of it. So now dA is 2 pi y dl, but dl is something which we have discussed in the last class. For any shape, how to find the dl? So we apply the Pythagoras. So dl we can write as if I take the base as dx and height as dy, using Pythagoras theorem, what we can write, dl square equals to dx square plus dy square, and we can take dx square common. What will get? dy by dx whole square. And if I take the root, it will come 1 plus. Okay, I don't have space here. I'll write somewhere else. Okay, I can write here. So dl we can write as what? 1 plus dy by dx whole square into dx. Understood? Is it very difficult? The answer is no. This should not. This is simple of Pythagoras. So to get the slant length, this is the trick. Okay. And therefore, this area becomes 2 pi y. And okay, dl I can. What I'll do is I'll substitute the dl separately. So let's find the dl first. Y is given to us, and because y is known to us, can we find the dy by dx, guys? Yes or no? If y is root x, then dy by dx will be how much? Who will tell? So use the power formula and tell me the answer.
One by 2 root x.
Very good. Okay, so if this is 1 by 2 root x, so we can get the dl. So 1 plus 1 by 2 root x whole square into dx. So dl turns out to be 4x square. So this we can rewrite as what? So dl turns out to be this value. Yeah, or you can write as x square plus 1 by 4 by x. I think this is also fine. No? So now comes the dA. dA is 2 pi y dl. 2 pi y is root x and dl is so it turns out to be something difficult, not very easy. Upon root x. Oh my god. How to solve this question? So it is now 2 pi under root x plus 1 by 4x dx. And then I have no clue how to start this integration. But anyway, the answer will be
So
there.
in the third step, wouldn't it be, sorry, fourth step, wouldn't it be 1 by 4x, not x
One,
square?
where?
In the
Here.
left column, left, in the fourth step. Yeah, just before that.
This one.
Wouldn't it be 1 by 4x?
Ah, it is 4x actually. Yeah. Yeah, it is square. No? Oh my bad. So this is a whole mistake from there onwards. Okay, good you pointed out. So I think everything is wrong. So DL is how much? It is okay. 1 plus 1 by 4x. Just keep it this. Leave it. And therefore, the dA will be how much? 2 pi y dl. Now this is fine. I can take x inside. What will I get? This is so easy, right? Now this is purely integrable function. It is square root of number, and we know how to integrate. So the area becomes how much? 2 pi, and it is like x plus some constant, which is not going to affect the formula. And the x will go from where to where? It will go from okay, 0 to r square, because the height is r. So to find the x value here, when y is r, x is how much? So x is r square. So the limit of x integration will be 0 to r square. And root x integration is same as x root of x plus some number, will not affect the answer. Or if you're not even comfortable, you can write as z and same. So anyway, the answer is how much? What is the integration of root x? Power 3/2. So the answer is 4 pi by 3, and r square minus 1 by 4 by power 3/2. Okay, so not a nice answer, but okay, there is an answer. Tell me. So any doubt in this? How to find the S area? So
No,
you can
that's-
find, yeah, you can find any area, any surface area in the world. Like if you know the surface, and of course, that the function should be integrable at the end, but you know the method how to get to the area part. Okay. So if you need some time to find the area, you can do this trick, you'll get the answer. Now, why these all are important ideas? The answer is simple. In physics, when we say derivation, and generally students find derivation very difficult because the derivations are based on this elementary method of taking areas. So only if you're good with the taking elementary, you can do the derivation. Otherwise, you have to just wait and watch till the derivation is performed, written in the classroom. So I want you guys to do the derivation on your own by taking elementary on your own. Then almost 50% physics you will find quite derivable for you. So that makes things quite easy. The next concept is again very simple. We will do the calculation of volume. So again, the only volume which we know, what is the formula for volume? Tell me, anyone knows the volume formula? So it's difficult for me to create this random shape. I wish I can recreate this part. Okay. Mhm. Mhm. No, somewhat. Okay. So believe that this is the same cross-section shape. So what is the formula for volume? If you remember the vector chapter, we found the volume of a parallel pipe. Do you remember this? If we have three vectors, so do you guys remember that chapter? The volume of a parallel pipe? So this is the basis of volume concept in physics or in maths, whatever. So this is like a, this will not give you better satisfaction. So I'll make it like this. So what is the core principle of any volume? What is meaning of volume actually? So let's say, so this is vector A, this is vector B, and this is vector C. Okay. So what is the area of the parallelogram at the bottom? This area is how much? That area is A cross B. And what is the direction of A cross B? So it is probably, let's call y-axis. So this is the A cross B uh, in the J cap direction, right? You can see. And now the question is how to find the volume. So volume is defined as area of the base into vertical height, or you can say it is the separation between the bottom and the top of the volume. And you can see the top and bottom here I have taken in such a way that the area, in fact, if you move from bottom to top, the cross sectional area you will see or found to be constant. Do you see that? Nowhere the cross sectional area is changing. Do you see that? So cross sectional area is same throughout. Yes or no? Tell me guys, yes or no? The cross sectional area
Yes,
is same. Okay. Now when cross sectional area remains same, then the formula for volume is area of the base into vertical height. That's it. And vertical height is nothing but this way. If this angle I call theta, this becomes c cos theta. And therefore, how to write the volume? We write volume equals to area of the base, and you take the modulus. So you take the area of the base into the vertical height, which is c cos theta. This is like a recap. And if you look carefully, this is A cross B mod of C cos theta. So these two are like dot product. So volume is nothing but A cross B. The first vector we can call A cross B as first vector dot second vector C. Because the angle between A cross B and C is actually theta. So the triple product, this is called the vector, scalar triple product, and this gives the volume. So volume is a simple formula. Any shape with constant cross section, into the vertical height, that is the separation. Because we have the topmost cross section here, bottom is there. What is the gap between them? So if I call this area as A, so this volume we write as H. And this is the formula which we actually apply for volume. Volume is always AH. Always AH. Yeah, always AH. So if I have a tilted object, then we draw a perpendicular and we only check the vertical separation. This is H. So we are not bothered about the slant length. In the volume calculation, what really matters is the vertical height, not the slant. To demonstrate why, let me give you the idea. So imagine you have a packet of biscuit, one packet from Marico biscuit. Let's call it. So the packet is almost cylindrical. So if you put the stack of biscuits one over the other, the shape that you will see is the cylinder, isn't it? Tell me, guys, yes or no? So if you put the biscuits one over the other, the kind of volume it will enclose is the cylinder. Yes or no? Hello, hello, hello. Yes or no? Tell me, guys. No.
Yes, sir.
Yes. Now imagine you give a gentle push to the topmost biscuit. So every biscuit is slightly ahead of the first. So the stack will look like this. Oh. If you tilt the biscuits, keeping one over the other, if I tilt like this, so by tilting, do we change the volume, or is the volume of the biscuit is going to be same?
Same.
And you can see why it is same, because we are not taking the slant length. Of course, the slant length will change, but the vertical height, or you can say the separation from the top and bottom, is still same. And not only that, what we really need is the vertical height, which is L sin theta. And also our cross-sectional area has not changed. So volume is area of the base into height. If the base area is continued throughout, it means the cross-sectional area is constant. When cross-sectional area is constant, then only you can write the volume. Otherwise, you cannot write the volume. This is as simple as that. So what is happening here? Here again, my cross-sectional area is constant. So I will write the formula as A into L sin theta, because my H here is now L sin theta. So volume formula is very much this. So when we need to take elementary, think about it. When you will feel that elementary should be taken. So we take elementary only when we feel that the cross-sectional area is changing. So when cross-sectional area is changing, what you do? You take a small slice of it, like a thin wafer. So you take a slice of it like a thin wafer, and a wafer thin elementary will maintain the cross-section throughout the height, isn't it? Can we see? So imagine the situation. What if I have a cone? So if you have a cone, what is the problem here? A cone cannot maintain the cross-sectional area, isn't it?
Yes.
And therefore we cannot write the formula area of the base into height. So in fact, we know the answer is 1/3 of that answer. Okay. So if the base area would have been maintained throughout, we know the formula is pi square h, because the base area is like a circle. So the problem is here, if I wish to find the volume of this cone, I have no choice but to cut into small pieces. And why we need to cut here? Because a thin piece will not complain about the change of area much. It's a very thin. I mean, it is so thin that you cannot imagine. So a thin slice will act as a cylinder, yes or no? So let's say from the tip, if I take this height as y, and if I call this is vertical height as dy. Now imagine we are trying to find the volume of cylinder. So what I need is the top surface and the bottom surface gap, and the gap is dy. We don't take slant. We take vertical separation. So what is the volume of this part? That's very easy, no? The volume will be how much? Tell me, guys. So how to find the volume of a thin piece, thin cylinder? For thin cylinder, the area will be constant. Yes or no? So can we approximate that? Okay, this is such a thin cylinder that the area is not changing by any significant value. Yes or no? So you can take this out. You can take this out, and you can treat as a thin cylinder. So it is a disc or cylinder. You can say it is like a disc or cylinder whose height is dy and radius is r. So what is the cross sectional area? So cross sectional area is how much? Tell me. Hello, hello, hello. What is the cross sectional area? Am I audible? Tell me. What is the cross sectional area of this cylinder? Come on, guys. What is the cross sectional area?
So
Pi
pi
r
r
square.
square.
It is pi r square. It's cross sectional area I'm asking, isn't it? So why it took so much time to answer this question? So cross section area of cylinder, we know it's circular area. So the area is pi r square. Yes or no? Tell me, guys. Yes or no?
Yes, sir.
But here the problem is r is a constant or variable. What do you think?
Variable.
And who is going to integrate? Our integrator is in your formula. Who is the integrator? Tell me who is the integrator here?
So dy.
dy. So the only variable that can be used, that can be solved is y variable. But we do have r. So what is the logical step to go further? What we must do to make this integration possible? Then what we will do? Logically, what we are going to do? So you have to replace it, na? That's it. What is the logical step? To make integration possible, you will remove the r. So first of all, you write the volume as pi r square dy, but this cannot be integrated unless we write r in terms of y, or we write y dy in terms of dr. So there are two possibilities. Now for any cone, we know the relationship. How to find the y r h capital R relation? So tell me the relationship between R, Y, capital H, and capital R. So what we can use here? You can use a cross-sectional, similar triangle. So if you use the similar triangle, what you get? This is Y. The whole length is H. And we have done this before also. So I expect you guys to tell me the answer. So what is the relationship between R, Y, capital R, capital H? Tell me, guys. Siddhant, tell me.
Yes, sir.
So
R by Y is equal to capital R by H.
very good. Excellent. So R by Y is capital R by H. Now capital R is a constant, capital H is constant. R and Y are related to each other. We always have to think about the relationship between multiple variables. So in a given shape, see the shape is a constraint. So things are varying as per some rules. So R and Y, it's a definite shape. So every shape which is definite will have a definite relationship between the variables. So definitely as Y will grow, R will grow, and that can be derived easily using a similar triangle. So we have R equals to capital R, Y by capital H. And now because we know R in terms of Y, what we can do next is we can substitute this R here. And once you do so, what will happen? Suddenly it becomes integrable. And your next step is, because it's going to be function of Y itself. So what will be the volume? Can you tell me the answer after substituting? Everyone, please. Everyone. Solve and tell me the volume which you are getting after integration. And the Y will vary from where to where to cover the entire cone. To cover the entire volume, what is the logical step? What is the limit of integration? Rugved, tell me, what should be the limit of integration? How the limit must vary to cover the entire cone? Tell me. Limit of
From 0 to
integration.
5.
0 to
Y.
0 to. So you have to cover the entire cone from top to bottom. How the Y must vary to cover from beginning to the end? 0 to
So 0 to H.
Plus Y.
0 to capital H. What happened to you? Why you are stuck in there only? Y is a general value. And then Y must change to cover this. Imagine that the slice is sliding. So you have to slide it from the tip to the bottom. So the Y must go from 0 to capital H, isn't it? Do you realize this? Yes or no? No. You don't realize this, what I just said?
Yes, sir. Yes. Sir.
So see, the whole idea is you're trying, variables are actually giving you the location of volume. So you have to add all such volume. So you must change the variable to trace through the every possible volume in the cone. And therefore Y must vary from 0 to capital H. And if you do so, you will get the entire volume. And then what is the answer coming? Prashant, tell me the answer. So the answer for the volume you are getting is?
Sir, I got it.
Very, tell me.
So pi capital R square H by 3.
Excellent. And that is the volume of cone, isn't it? You have done this. I mean, you must have studied about this in high school.
Yes.
1/3 of pi r square H, right? And we found even this answer using cylinder formula. So in the entire world, there is just only one formula for volume. The volume formula is area of the base into height. But what if the area start changing? We have no choice but to make elementary. And elementaries are such volume which are having constant cross-section area. So their area is not changing, and even though it's changing, it's almost negligible. So with that assumption, we can use the cylinder formula again, and then we integrate to get the actual answer. So I hope you can remember this, the idea. This idea is important, how to take volume. Is this clear?
Yes, sir.
So imagine this situation. So imagine a situation. Okay, let's find the volume of a sphere. So that's the only challenging thing. Volume of a sphere. So if I give you a complete spherical object, and because I'm asking you to find the volume, so definitely you will not cut with theta as angle. So here the method of solving question will change. When it comes to volume, the elementary taken will differ slightly. So how it will be? You make a parallel cut to the base. So if you think as an equatorial plane, you make a parallel cut, you move a knife across it, slice into two halves. This orange is now into two halves, but that is not sufficient. You need to make another cut just above it. I hope you can see the thin slice which you have made here. Are you guys able to see this thin slice? Yes or no?
Yes, sir.
So let's say this slice is cut at a height y, because we are looking for vertical height. And this is the axis of this disk. So if this is y, I can call this height as dy. So don't worry if you don't see it. It is very much thin. So now the problem is y is the only variable which I can take, and the radius of the sphere is capital R. So can you tell me the volume of this thin slice in terms of y and dy and R? Of course, you can choose R. So tell me the answer, everyone. How are we going to write this volume? Thin slice. So what is the volume? Come on. When you're trying to say this answer. Next year.
Pi r cos theta whole square dy.
See, there's nothing, there's no theta here. I mean, of course, you cannot use theta in fact. You must express the answer in terms of r, y, dy, that's it. The dy is definitely the height of the cylinder. So you're only supposed to find the cross-sectional area. And what is the cross-sectional area? Tell me, Prasan sir, what is the cross-sectional area?
So pi into y square plus r square.
Y square plus r square.
R square.
Wow. So you know Pythagoras theorem? Have you heard this name, Pythagoras? So let's call for the timing this radius as r. What is the relationship between small r, small y, and capital R?
R is r square equals to y square plus r square.
Which r square? Like small r square, you're saying.
Capital R square is equal to y square plus small r.
So what is r then? R square is how much?
Capital R square minus y square.
So what is the area of cross section? Area of cross section is how much? Tell me, guys. Area of cross section is how much? What is the area of cross section? What is the area of cross section?
Pi into r
Pi
square minus
r
y square.
square.
Pi into which r square? Small, na?
Capital R.
Capital R. The area of cross section is pi capital R square. Come on. You have a disk given to you, a thin cylinder, a disk, and you don't know find the area of the disk. Come on.
So I said capital R square minus y square.
Okay. Then this is the correct answer. So area of cross section is how much? Pi capital R square minus y square. This should not be difficult, but still, if you're facing difficult, I can understand. It's the beginning of a journey in mathematics, so it is natural. Even something very easy and very rudimentary will appear difficult because somewhere your brain is not open. It's closed brain. You have to open it to take it something fresh in your memory. So what is the area? See, you have to look at the diagram and tell the answer. It's not that difficult, but I know even that it's difficult to look also. There are so many constants we don't see with eyes. We see with eye and brain coordination. So your brain is somewhere occupied. So you're somewhere lost in your thought, and therefore you don't see even the obvious. And that's very much natural. Don't worry about it. It happens. We see with time. Okay. Everything coming to you is not visible to you. And it is true with every human being, not only you. With me also. So something which is very obvious, it appears. I mean, actually you will start seeing things after a long time. But it's good to see it as early as possible. That is like a bonus. So are you guys able to see the area of cross section? Yes or no?
Yes, sir.
So can you write the volume now? So what is the volume? D volume is how much?
Pi into r square minus y square into dy.
Very good. Now comes the to find the total volume, you are going to integrate the dV, right? This is what you do. And therefore you write a pi r square minus y square into dy. So what kind of a variable do we have here? What kind of variable do we have here? The y is the only variable.
Yes, sir.
Now, as you will change the y, the disk will shift the location. So to cover the entire sphere, how you must vary the y? Can you guess? From bottom to top, you have to cover the entire sphere. So tell me how you're going to change or vary the y value such that you get the entire sphere covered. That's the whole idea. Is it difficult? Is it difficult, guys? Tell me. Yes or no? So tell me the limit of integration first of all before you solve. For what value of y, think in terms of coordinate system because y is a coordinate. So for what value of y, you will get the bottommost point.
0.
So bottommost is at 0. Are you sure? See, it is like, again, you're also not seeing it. You're thinking right now. You're not seeing right now. Can you see and tell? I don't think it's difficult if we start seeing. If we all start seeing things the way it is, a lot of things will change in the world.
0 to capital R.
But where is the, how you measure y in coordinate system? Every distance we measure from where? Origin. Y is a coordinate and the measurement is done from the origin. Yes or no?
Yes.
So 0
from-
to capital R.
So 0 to capital R will only cover the upper half. No? I mean, saying you have to cover the entire sphere. Can you think about it? It is so difficult. The limit of integration will be from. Okay, tell me, what is the y coordinate of the bottom? Right, mathematics. What is the coordinate of this point?
minus R.
No, it is 0, comma minus r. And what is the coordinate of this point?
0, comma R.
So how the y coordinate is changing? Can you guess?
From minus R to R.
Correct. So now you're expert. The moment you start seeing, things will change in your life. So are you guys finding it difficult to see? Isn't it? Even though it's very much obvious, but at very first go we don't see, and that's very strange also. And it is fascinating, okay, that we don't see things even it is in front of us. So to see something in front of us, we have to kind of absorb the context, the background. And these are some very, you can say, physiological learning difficulties, which we all go through. Slowly you start seeing things. So when you go deeper into seeing, that is called observation. So observation is different from seeing. So everything we see, we don't observe. I mean, observe means you have the analysis going on in the back of your mind, and you see a lot more than a person who regularly see. That's why a scientist and a commoner, they only differ in the observational skill actually. So if you want to become a science or a close to scientist, see, of course, we all can become scientists, not a big deal. So to become a commoner to scientist, the only difference is you have to improve the observational skill actually. Okay. So that is one skill that we all grow if we are interested. So now I hope you can do the integration. Yes or no? It is totally integrable, I think. You can split the two parts and integrate each part separately and tell me the answer. So could you guys tell me the answer after solving? Please go ahead and do it. And yeah, no need to worry about all these things. I mean, things which are simple, still you're not able to see. It is very much normal. I mean, we all go through the same process. So even I was not able to see things. So I realized that okay, when this process is started in my brain, suddenly the entire way of looking at things changed for me. And then I found the kind of redemption that the world is not so complex. Just we need to improve the observational skill. Do this. So this is a big journey, journey from commoner to scientist. improve your observational skill. Yes.
Done.
Very good. So how much you getting?
4 pi capital R cube by 3.
And this is exactly the formula of a volume of a sphere, right? 4 by 3 pi. We all know this answer. So not today you have derived it. Was it difficult? Maybe. I don't know. Was it easy? Maybe. Even I don't know. So you all have to do this practice to realize the importance. So we'll see some examples that why we need to know derivation. Okay. Is it done, guys? Tell me.
Yes, sir.
Okay. So let's see the application. Like why in physics these kind of elementary ideas are important. Okay. So to demonstrate, I'll start with something very simple, something which you guys are aware of, and that is called calculation of potential energy. Calculation of potential energy. So tell me, if you have a small object at a height from bottom, small h, mass is small m, and if the earth surface is the reference, so what is the potential energy of this ball with respect to reference? Anyone knows the answer?
mgh.
Excellent. So how many of you are not aware of this formula? I mean, raise your hand if you're not aware. Rugved, you know this formula?
Yes, sir.
Prashansha, tell me.
Yes, sir.
Shreya, you know? Okay. Excellent. So I hope you all know this formula. So I'm so glad. So now see how this elementary idea is important. Before you write anything in physics, it comes with some assumption. So if you look at this formula carefully, now again, this is again from the commoner to the scientist. We are trying to improve the observational skill. So how to improve the observation? What is the meaning of observation? You see things, of course, things are in front of you. So your eye is able to receive this light and you are able to see. Let's think beyond what you see. So you see a particle called mass m. What is given that this mass is located at a height h from the base. And when a mass is located at a height from the base or the reference, then its potential we write as mgh. All right. Now look at the simple scenario. If I give you a rod, let's think the rod is uniform rod, and it is neither tapered, so it's a very much having uniform cross section from bottom to the top. And because the mass is uniformly distributed, so the entire mass of the rod is smaller and the length is L. And what is given, that mass M is uniformly distributed over its length. Simple. Now, can we write the formula potential is equals to mgl? Is it correct formula? Yes or no? Is it the formula correct?
Yes, sir.
Why you are saying correct? So, do you see the mass kept at height L? Is it same as the previous question? Is the mass kept at height L? Or mass is distributed till the height L? What is the difference? First of all, is it a point mass?
No, sir.
Is it the mass which is exactly L height above the reference? Answer my questions.
No, sir.
So what prompted you to say this answer? The answer is lack of observational skill. Yeah, that's correct. So just a minute, just okay. So now, what is the way of getting it? Like you know the formula for a particle. Is the rod like a particle? Yes or no? So rod is a particle. Rod is a body. What we say?
The
Rod
body.
is a body. So it is called distributed mass. The mass is spread over, let's call length L. So when we have a distributed mass, then we can pick one piece of it. Okay. So we are supposed to pick one small piece which can mimic the idea of particle. So because we are solving mathematics and we are going to pick some mass, so we must do it in a mathematical way. So what we do is, because the mass is spread from bottom till height L, so I'll choose some random location. Let's call the random location is located. So I'm here. So where I am at height y from the reference. So this is my location. And there I pick a small piece of the mass. So what I do is I cut a small piece and I say this length is dy. So mathematically, you move y and then you cut dy. That's called the element. Now this element which you have cut is like the ball. Now this is, you can you relate these two events? Are these exactly similar?
Yes, sir.
Now because the situations are identical, now you can use the formula. It means every physical formula, any you can say relationship in terms of function is applicable under certain context. If the context is not met, you're not supposed to use it. So the first step of doing integration is we match the context. So we think, okay, is it matching or not? So what is possible, action that we must take in order to match it? So those possible actions you have to think about. I mean, this is of course a learning process which we develop. Okay. So you have to think about the action. And that action is very simple. We know that this elementary is cut and this elementary is located at a height y. Okay. Now, can we write the potential energy of this particle? Because it's a very small particle, so the mass which we expect is also going to be very small. The m is mass for the entire rod. So what do we expect the mass of this part? Can we call dm the elementary mass? Because it's a small piece, so we expect its mass to be also very small. Yes or no?
Yes.
And now this elementary mass is located at what height from the reference? Can you guess the height?
Y.
Y. Very good. So we will write the potential energy by the symbol du. So you will learn later on in physics, we write potential as capital U symbol. And because now we are into the identical situation, we can add the formula mgh. So what I should write on the right hand side? Tell me guys. So we are adding potential of the dm
GY.
gy. Excellent. Now dm is the mass of the rod having length dy. So can you find the mass in terms of capital, small m and L value? What we use is unitary method. So I hope you all know unitary method. The L length having m mass. What is the mass of one length? Tell me guys. Mass of the m by L. So what is the mass of dy length? The mass of the dy length is how much? Tell me.
M dy
M.
dy by
dy
L.
by L.
Very good. So is it difficult? Sorry. So for dy, this is the mass. This is the mass of dy length object. So this is we have called dm, right? So dm we can write as what? M by L into dy. Do you realize this? Okay. And now what we can do? We can add the formula. Du equals to m dm g y, which is actually mg by L into y dy, and this we call du. So if we integrate now to cover the entire rod, to find the total potential energy, the y must vary from where to where to cover the entire rod?
0 to y.
0 to 0 to
L.
L. Okay, Rugved is getting stuck in this part, I think. See, you have to y must vary to cover to cover the entire rod. So how you're going to cover? Yeah, you see, you're not supposed to tell me the location of element T. To cover the entire rod, the y must vary from where to where? Rugved, that's to you.
0 to L.
0 to L.
Yes.
So what is the integration of y dy?
Y square by 2.
And if you put the limit, then what will get after putting the limit?
L square by 2.
Very good, excellent. So y L one will cancel out, and you see the answer is mg L by 2. mg L by 2. It is not mgl, correct? This is wrong. Now we have realized this. This is not the right answer. What is the right answer? mg. So the right answer is mg L by 2, isn't it? Do you guys realize this part? Yes or no?
Yes.
So this is the most important idea in not only in physics but everywhere. Whenever you solve something differential, every physical formula in which you come across, every physical formula, when we write under some condition or context. So whenever there is a mismatch of condition or context, we don't write the formula. So then to reuse the formula, we have to do some elementary action. So we cut something element. And the moment we cut something elementary, we are able to do this, able to use the physical relation, because elementary is cut in a fashion that can allow the formula to be used. And then once we do so, we integrate to get the net answer. Okay, so I'll give you one slightly difficult formula. And these are like challenging for most of the students, they who are in class 12th also. But I expect that, okay, you can do magic here. So imagine if I ask you a question, like, what is the potential energy of a cone? Imagine, this is the question. And all right. Understood? So this is your coordinator, and this is the axis of the cone. The actual height is capital H. Although radius is not required, so let's say radius is small, capital. And the mass is capital A, or you can say small a, whatever. And having uniform density, density is uniform. So again, is it a mass which is fixed or distributed? So it is a distributed mass, isn't it?
Yes.
Yes, sir.
And you can clearly see that every mass is having different height. Okay, so it is not the same height. But if you remember the elementary, the way we took earlier, we can cut a slice like a disc. And tell me, the slice will look like a what? Slice will look like a flat surface,
A cylinder.
a thin cylinder. And that thin cylinder will have the fixed height from the bottom, isn't it? So for that thin cylinder, if you take any point on the cylinder, will have same height, yes or no?
Yes.
So height wise, a thin cylinder will represent the constant height object. So within that thin cylinder, do you think the height will change for every point? Or remain same? Okay, let me draw something. Probably this will help you. So if you cut a thin cylinder, then technically the height is not changing. Huh? Do you realize this? If I call the height of the cylinder as y, then this height is true for everything, every point on the cylinder.
Yes.
So if I move y from the bottom and if you cut a dy thickness, can we use the formula of potential energy for this entire disk? Yes or no? Can we use? Tell me guys, can we use?
Yes.
Yeah, we can use. Why we can use? Because the height is same for all, right? The h is not changing for the disk. So in the formula mgh, the h is representing the height of the mass from the bottom. So here y is representing the height of the entire disk from the bottom. Yes or no? Tell me guys, yes or no?
Yes.
So the biggest problem here is, okay, we know the potential energy we can write as formula. What is the formula? So if I assume its mass to be dm, the way we assume, how to write the formula in terms of dm, guys? Potential energy equals to
PM, G, and D, Y.
gm, gn,
And Y.
and
Y.
y. Excellent. Very good. Now the question is, how you are going to convert a dm in terms of y? Is it uniform? Like here, the cross section area is changing or constant?
The changing.
So we have to write the answer in terms of density because it's a three-dimensional object. So a cylinder will have mass equals to density into volume, and we know how to write volume, isn't it? We know volume of element. We have done this before. So you will move y and you will assume this as radius r, and then you can replace r in terms of capital R, small r, y and h. So you have to do a lot of calculation, but you can do it. So can you write the d volume, substitute in terms of y and do the integration and tell me the answer? So tell me the answer in terms of density. You can choose the row as a symbol, write d volume from the previous discussion, and whatever time it takes, I'm okay with this. You just solve it. Take your time. There is no need to hurry and do some mistake. Think step by step carefully. Write everything step by step, and see with this much learning, are you able to derive? So it will be a big day in your life if you can derive. So are you guys solving it? Yes or no?
Yes.
Yes.
Very good. Go ahead.
Sir, I got the potential energy.
Yes, so tell me the answer.
Rho pi r square h square g by 4.
Like this.
Yes, sir.
And now what we can do is density is defined as mass upon volume. And we know the volume of a cone, right? So once you substitute this answer, what will happen? Tell me the answer. So I can get the answer 3 by 4.
mgh.
And this is, I will read that as mg and that is the answer. And later on, again, we will come to know that 3h by 4 is called center of mass, height of. So that's really interesting, and it's congratulations, we got the right answer. So super job. Rugved, Prasansa, Shreya, are you guys able to progress with your calculation, or are you guys stuck? Need some help?
Sir, I didn't get the by 4 in potential.
Integration.
Yes.
So maybe the integration part, I mean, the function you got is not as per the expectation. So tell me step by step. Let's do it step by step. So first step is you simply write the volume part. Just forget about everything else. Can you guys write the D volume separately? Tell me.
Pi r square dy.
Yeah. So now the question is how to replace R. That's correct answer. I study was correct. Now the next step is replace R in terms of Y. And for that, if you remember, we use the similar triangle idea. So you use it, or you can use tan theta, but making some angle theta.
Pi r square y square by h square dy.
So tell me the R, small r in terms of small y relation.
capital R into Y by H.
Excellent. So the first journey is complete. So you got the volume part, right?
Yes.
I think the rest is simple because you have to just substitute the formula. So you have to add density into volume formula into G into Y. It is simple Y integration. So if you integrate Y, what you get? You have Y cube, right?
Yes.
So Y cube will give you Y power 4 by 4, no?
Yes. Yes.
And the Y will go from 0 to capital H. The
Yeah.
limit of integration is 0 to capital H. So once you write the limit, you will get the right answer. So can you do it now? Complete.
Yes.
Prashant sir, you got the idea? Prashant sir, you got the idea? Are you there?
Sir, I got it.
And now the answer is matching.
Yes.
Okay. So of course we are not going to solve every physics right now, but the entire idea was that can we see through the purpose, and if these two examples are enough to give you the purpose, then we can move ahead and we can stop this part, the part we are discussing now. So are you guys now okay with the purpose why we are doing all this? How elementary is so useful to us?
Yes, sir.
That was the purpose. Purpose is very simple. Now, this is not the only way. Sometimes there is a trick also. So we have derived the formula for the volume. Let's see the last way of. For a spherical object, we have some other method also. So you can think a sphere as a stack of shell. You know what is the meaning of a stack of shell? You can imagine it is made of thin shell of varying radius. So let's say at a r distance from the center, if you imagine a thin shell of radius dr, and dr is really small. So you can think this as a orange peel. You can think as an orange peel. Compared to the volume of the entire orange, what do you think the volume of the peel will be? Because the peel will have some thickness, isn't it? The peel is not of zero thickness, it will have some thickness. So what we do is we move R and then we make a small thin, we just peel off a small thickness. And this thickness is of value dr. So you can imagine that this is a thin peel which is enclosing a volume equivalent of the sphere of radius is small r. And its own thickness, we call it dr. So what is the surface area of a sphere formula? What is the surface area? For any sphere of radius small r, what is its surface area? Tell me. You know the answer. Surface area of a sphere is
4 pi r square.
4 pi. Excellent. So that is the right answer. It is the 4 pi r square. The next part is dr is so small. Can we think that this area is almost maintained up to dr? Can we say? So
Yes.
from R up to the next layer dr, the cross-section area is almost same. So if you peel off, if you take this peel off and if you spread on a plane surface, you can imagine that you have peeled off and you put every piece properly. And you can see this is the thickness of the peel. So I put a peel in a really nice geometrical shape. So what is the total surface area of the peel? From the top, if you look from the top, this area is how much? Can we say it is 4 pi r square? Yes or no? It's the same peel which I have put over the surface in this shape by cutting into small pieces and rearranging. So I can really achieve any shape. And then what is the thickness of this peel? dr. Do you guys realize this? Yes or no?
Yes, sir.
So if you simply take away the peel and put on a surface, so its surface area is 4 pi r square, thickness is dr. Tell me what is the volume of any shape? Volume is how much?
Area into height.
And here area is constant, right? Area is constant, isn't it? So area into height will be how much?
4 pi r square dr.
Exactly. It is a surface area into thickness. It is the volume of a thin shell. This is called volume of shell. The volume of a shell is surface area into thickness, which is 4 pi r square dr. There are many ways you can derive it. If you use the formula 4 by 3 pi r cube, the volume formula, and if you differentiate with respect to r, you get 4 by 3 pi. And what is the d by dr of r cube? Tell me.
3r square.
d. This is 3r square. 3 gets cancelled. So what you can say? dv by dr is always 4 pi r square. Therefore, dv we can write as 4 pi r square dr. Okay, this is a method 2 of getting it. This is the direct answer. Okay. Then I'll show you the third method. So third method is pretty much what we do in our high school. Imagine it's a, okay, just I'm zooming out for your own understanding. There is no purpose here. So we have a radius r. So let's say we have a sphere of radius r, and we have another sphere of radius r plus dr. And we're looking for which volume? We're looking for volume between them, right? So we are looking for pretty much this volume. So the basic way of writing volume is you write the bigger volume, which is 4 by 3 pi r cube minus small volume, right? This is how we do in high school, isn't it? To find the volume between the two surfaces. So this is pretty much 4 by 3 pi common, and this is a cube minus b cube. Tell me guys, what is the formula of a cube minus b cube? So answer is, it is a minus b, a minus b into a square plus ab plus b square. So how many of you know this formula? Everyone? Are you guys okay with the formula?
Yes.
So you can see something interesting. But what we're getting is 4 by 3 dr, and this I need to expand. So the way of expanding is simple. You can add a square plus b square plus 2ab. Same here, r square plus r dr, and then again same here, r square. All right, so see what you're getting exactly. So what we're going to get here is r square, 3r square. Very nice. And then 3r dr and dr square. Now always remember, dr is very, very small. Dr is very, very small. And because dr is so small that anything which is dr square or dr cube is negligible or zero. So if I multiply dr inside, what will get is 3 r square dr But the next term will become 3r dr square, which we can ignore. And the third term is in fact dr cube. So all these terms are so small. So as per the limit concept, this will be 0 tending to this is 0. So what we're left with? So for elementary things, we have to use the concept of limit, and you will get the answer like this. So why all answers are matching? Because in the world of elementary, things are pretty much simple. So elementary is in fact a way to go back to something basic and then solve it. So when we take elementary, we make sure that we are doing something really basic and things are applicable with ease. Okay. So this completes the mathematical tools. And from the very next lecture, we are going to start the kinematics. We'll go pretty fast now because we have spent a lot of time in learning maths. And the purpose is that you can use it faster. So what you are supposed to do now? You're supposed to revise entire maths, basically beginning from vectors till trig. No need to go and watch the video, but just observe. I mean, go and revise the notes and try to complete it. Okay, guys? Any doubt in
Yes,
this? No. So are you guys ready to now learn physics?
Yes,
Are you guys excited now? That now you are going to start physics actually. So see you in the next lecture with kinematics. Bye.
bye, sir. Thank you, sir.